Okay, so we're gonna do a little example I found online, and this is a recursive function example. It's basically going to be a function that creates all the possible permutations of a string that is inputted to it. Let's go ahead and define that function first. Just writing the function definition here, and then some string is the input variable. So basically, when the user calls this, based off of what we see here, I'm just reading off of this example, we want permutations, example ABC, maybe that's their input string. They want that to return a list with ABC in it, ACB, BAC, you get the idea. All the possible permutations. Got it right here. Excuse me. So, how do we approach this problem recursively? Well, let's take a look and see. So we need to, let's do this by hand. I think that's a good way of looking at it. So if we have ABC, right, how do we compute all the permutations? Well, first thing you would do is easy. I'm just going to take the first term here and move it to all different locations. So the first permutation would be ABC, then we have BAC, and then we have BCA, right? And boom, we've just figured out one of the possible permutations. But we also have to worry about B and C, right? So let's say B and C are switched. So now we have C there, right? And then we could do two things. We could keep moving C again, or we could move A. If you've ever done any sort of permutations before, you know it's a lot easier to just switch these guys and then move A again. So we'll do CAB and then CBA, right? And now we've just calculated all of the permutations. There's no other way we can make a string with these same characters that's different than this 6, right? So what did we do here? Well, first off, we took the original string. And there are many approaches you can take to it, but this is how I think through it. So I took A, and then I took a BC. I split the two, and then I fit A, right, into the middle. We put it there, and we put it there, right? And that made up our 3 permutations for this first case when we had BC. But we also have to remember that BC can be broken up into, so BC has permutations of its own. And BC has permutations BC, B plus C, which can only be divided 2 ways. It can only be divided into CB or BC. So first thing that you really need to do is you need to divide it up and make it easier. So A plus BC, we know that BC has permutations BC and CB. So what we really have here is we have 2, we have A plus CB. And the plus is just representing that I'm going to permutate A through CB. So it's not mathematically adding the 2 together. So maybe a comma is better. So then we would take these guys, right, and we would get ABC, BAC, BCA. And this part's really easy. So if we take this guy right here, how do we make a for loop that puts A into each location? Well, let's do that first. So for, we'll just call it I for index, in range 0 to length of, and in this case it would be BC, but we just want it to be some sort of variable. So we just want, we'll just call it for now, because it's not some string, we'll just call it short string. I'm just going to define it here as something. We'll get rid of this when we finish our actual code, but I just want to go over the for loop part first because it's a non-recursive part. So we have short string. In this case, short string is just equal to BC for this example we're doing here, right? And then we want to loop through all those guys, and we just want to put A, which is our index character, or our start character, A in between each of those index points. So what's range 0 to length short string going to do? It's going to go through and it's going to make a range from 0 to 2, right? So 0, 1, 2. We're going to put our A in between each of those locations. So how do we do that? We would have some sort of list to store all these permutations in, right? So permutation list equals 0. We'd say permutation list plus equal, so we're adding a list to it. And this list element is going to have short string from beginning, right? That's what the colon represents, to I, plus start character, plus, and then we're going to go from I to the end. So remember, when we're indexing a string like this, the ending index is not actually included in that. So if the example was I is equal to 1, for BC, we're actually cutting off the C, so we're going from 0 to 1, up until 1, but we're not including 1. So C is the index at 1, and then B is the one at 0, so we're actually only including B, right? So it's saying, okay, we're going to put A from index 0 to the end. So right here's index 0. If index 0 is the end character, it's not included. So we put A at the beginning. And it's going to go.
I'm having trouble hearing you.
Siri wanted to talk. Then we would go and put A there. And then A at the end, right? A at the end would be when I is equal to 2. So that means that it would include C. It would go 0, 1, right? Because it's important to remember that the length of a string starts at 0, just like a list. So B is at index 0 and C is at index 1. All right, so we take that, we loop through each of the elements in there, and then once we've done that, we add those all to our permutations list, and this will work fine for ABC. It's going to basically just take all those, add them to the list. We can test it here if we make it return permutation list. Yeah, this is all gonna, it's not gonna like any of that because it's not commented. And then we have this guy, start character, plus, we need to do index over short string. So I just forgot to type short string there. So indexing over short string. All right. Permutations. Now it doesn't matter what we input to it, right? Because we have these predefined variables, start character and short string. So this is more just a test case. And it's not happy. So permutations list reference before assignment. Permutation list. So I just typed it wrong there. We're doing this live, baby. Permutations. All right, there we go. ABC. BAC. Oh, you know what? It does need the +1 because length of short string is 2, so it's only going from 0, 1, but we also want to add it at the end. Okay, sorry about that. So the issue here, as I mentioned, we need to add +1 to it. The reason being, the length of it is going to be 1. We need to add it to the end character, right? So if we have BC as our example, we have to go ABC, BAC, and then BCA, right? So this range won't include that last number. So we're doing 3 iterations, but the length of short string is only equal to 2. So it's only going to give us A, BC, and BAC. Adding that +1 allows us to add the last term as well at the end there. So that's why we need to add that. Okay, now let's run this. Permutation. ABC, BAC, BCA. So boom, we just figured out, Siri just really wants to talk today. We just figured out how to do that first part that we were talking about, where if A plus BC, how to make a list for that guy, right, with the ABC, and we just calculated that here. And now, in theory, we could just have it do it again for CB, and we would have our total permutations for ABC. But that's a specific case. We want it to work for everything, right? Not just that specific scenario. So how do we do that? Well, what are we really doing here? What we're really doing, where did BC come from? BC came from the iterations of that second part of ABC, which happened to be BC, right? So what we really did was we took ABC, we cut off its back half, which is BC, and we plugged it into permutations. And hopefully, if we code permutations right, it should be taking BC and returning us a list with BC and CB in it, right? Those two terms. And then what we really need to happen here is we need it to then, once it's done with BC, do the same thing again, but for CB. So if you're starting to think here, you may notice this is a list, and we're going through each of the permutations inside of this list. So we are actually going to iterate with a for loop. You may be like, aha. So we're going to take this list right here, which we get from permutations of BC, right? Where does BC come from? Well, if we assume that some string, which is the input for the function, is equal to ABC, we're just cutting off that back half. We're taking the first character, and we're taking the last half, and we're finding all the permutations for that. And now we can get into the iterative step. So we want to loop through BC and CB in the case of ABC. So we're going to do for permutation in, and then we're going to call permutations again, right? Because it returns a list of all the permutations for that string. And then we're just going to truncate the string. We're going to go from 1 to the end, right? So we're just removing that 0 character. And then at this point, you can probably already figure out that start character is just some string 0. It's that first character in the string, right? And then I guess you could do this here. So for consistency, short string is 1 to end. It's that last half. And then we would just put short string into permutations. So now in the case of ABC, like I said, it's cutting off that BC. It's finding all the permutations for BC. Likewise, if it was BCD, it's taking all the permutations for BCD, which would be, you know, BCD and then CBD and then blah, blah, blah. And you may notice that you would then, when it calculates permutations for BCD, it'd have to split that out and calculate the permutations for CD and then loop through each of those. So CD and DC, and then put B in between each of those. B and B, like through it, and then the same thing for DC. So the point I'm trying to get at is you're permutating over each of those ending, and what that is that's recursion, right? Because what you're really taking is you're taking permutations again, all the permutations of this ending, and then you're just moving B in between each portion of those permutations. And that's what we're trying to do here with this line is we're saying, okay, I want to take each of the permutations for the ending characters, right? So in the example of ABC, D, that would be BCD. So we can just assume permutations BCD is going to give us a list of all the permutations for BCD. And I want to take each of those permutations. The first one would be BCD and then CBD and vice versa. And I want to then loop through each of those permutations and put the starting character, which would be A, right, the 0th term of the string. And I want to put that in between each of them. So then I would go through BCD, put A at the beginning, middle, relative middle, and then end. And then it would go and do the same thing. And each time it's doing that, it's creating a new string and it's adding it to the permutations list. So now that we understand why we're doing that, and we look through this for loop, we have almost everything here except for one thing. So we've added recursion now, but we haven't added a base case. So in fact, we can run it here and see what happens. Time function. Yeah, we'll get rid of this. Screw that. And then then, whoops, once again I have decided to just leave out some string for some reason. Haha, pun. Short string, and I forgot a colon. We're doing it live, baby. So permutations. Some string will do ABC. And then we get this ugly thing. String index out of range. Ew. Line 7. Line 10. When it calls the permutations. And the issue is, as you might have guessed, eventually we'll get to a point. So it'll go ABC, right? And then it's going to do all the iterations for A with B, all the iterations of BC. Well, we calculate the BC ones, so we call permutations BC. And then when we do BC, it calculates permutations C. Well, there's only one permutation for C, but the problem is it doesn't stop after that. So what it's doing is it's cutting off this ending part, but there's no characters after C. So when it gets to permutations of C, some string is 0 is C, and then some string 1 to the end is just nothing. It's a blank string. And when you try to run that in the range here, you're going to have it going from 0 to 1. Well, 0 is fine. There's no character at 0. It's just blank. But then once you get to 1, well, that's out of index because there's no second character at 1. So you're getting an error because it's trying to put C at 0 and 1. You can't do that because 1 doesn't exist. So how do we do that? Well, we need to add a base case, which you guys have probably talked about in class. So the base case in this example, if you want to take a crack at it, it's going to have something to do with C here. And we can think about it more logically and recursively. So once we hit the letter C, what happens? Well, when it called permutations again, that caused an error. It's important to note, though, that C only has one permutation. It's just C. You can't permutate a single character in any other way. That goes for any character, so we can make a more generalized rule here. So if n is a character, then it is its only permutation. Well, how do we check if n is a character, if n is a string? By checking the length of n. So length of n is equal to 1. So now, when length of n is equal to 1, we know that it is a character. And we can just return n because it is the only permutation. The only permutation. You can't make any more out of a single character. So we need to check for that. So let's add an if statement here. So let's say if the length of some string is equal to 1, then we just want to return some string. There's no other permutations. There's no need to make a list for it. It's just that. It's that string. And now that we have that base case, this should fix our index out of range. And we could test it here. I've got to get rid of my notes there. Okay, permutations, ABC. And now, as you can see here, we have our permutations for ABC. We can then do permutations ABCD. Whoops. Forgot D. There we go. And as you can see, it gets much bigger. A lot bigger there. Permutations ABCDEF. As you can see, it's so big it can't even fit it all in the console, so it squeezes the text. If we open that up, there's a ton of permutations, right?